Hello students, my name is Shubham. I am your chemistry tutor and today we will study about the reaction mechanism, which is the most fundamental one and the important topic for JEE chemistry. And basically it is a class 12 topic. Before that, in the class 11th, you must aware few things and you should revise few things such as the general organic chemistry part, the stability of cations anions, or acidity and basicity order, nucleophilicity order as well, mesomeric effect, inductive effect, tautomerism, and a few more things as well, which is written here. You must aware also the chiral center in HMR diastereomer so that you can easily understand the radioselectivity and the stereoselectivity things, which is like if you predict them. So first, before jump into this, you should ask yourself that why we study, yeah, that why we should study the general uh, organic reaction mechanism. So by the name itself you can understand there are thousands of reaction in the chemistry. Some reactions are inorganic, some reactions are organic. So you get easily a benefit by study this topic. What is that? You can understand the mechanism. If you understand the mechanism, you can easily predict the products, that what are the products made after a two solvent, two solute, or solute and solvent react with each other. Okay, so if we divide organic reaction mechanism into few topics, then what are the types of reaction happen? So in the organic chemistry, basically we divide few types such as electrophilic substitution, nucleophilic substitution, electrophilic addition, electrophilic aromatic substitution reaction, elimination reactions, such as E1 reaction, E2 reaction are elimination reactions, SN1, SN2, which are the famous one. Many questions are coming from these topics also, and the carboxylic reactions, so that you can remember all the things, and like how the salicylic acid formed and other things as well. So how a reaction proceed? Suppose take A and B. What are these? These are reactants. So if we add A and B, then it will react or not. It will depend on the medium also. So it can be solute, solvent as well. When two or more solute and solvent react with each other in the favorable condition and the product is made, then reaction happened only. And in organic chemistry, you must also know and aware about the solvent part, so that you can easily understand what are the products made, what are the majority of products. If two products are made, which are of majority, which are of less stability, you can easily predict them also. So before understand these concepts in a more deep manner, you should understand also first the solvent thing. So what are solvents? Basically, solvents are the medium in which a reaction occurs. Okay, and solvent is probably or mostly times more than solute. If we talk about when the two reactions are occurring, then mostly the solvent is of more. So solvent, if we talk about the solvent is of different type. But first we should understand the definition also as well. So if you want to, you can easily understand that a solvent is what? Solvent is a medium in which a reaction take place. Okay, and it helps dissolve the reactants and sometimes also precipitate the reactions as well. Solvent are broadly classified in mostly two categories, which are, the first one is polar protic solvent, and the other one is polar aprotic solvent. So the two types of solvents are here. So if we discuss the first, what is polar protic solvent? By the name itself, these are polar. Okay. So as we understood already that we are talking about polar thing here, and what is non-polar. So we understood already in the dipole moment concept, which you studied already, I think, in chemical bonding also in class 12th. So when dipole moment we denoted as mu, and if mu is not equal to 0, then it is what? Then it is polar. And if mu is equals to 0, then it is non-polar, because no polarity stands here. So talking about non-polar solvents are like examples. If I have to give examples, then you should guys know the examples are CCl4, so that the all the polarity cancel out in the what? In the compound, just like a C, Cl, 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 all are in the different directions, so that all cancel out each other and its polarity in the compound is 0. And such as CS2, carbon sulfide, and hexane, no, mostly the benzene, it is normal hexene, benzene, etc. And polar solvent are those solvent which the dipole moment is not equals to 0. So now as we know about polar solvent and non-polar solvent, now we further classify polar solvent into the polar protic and polar aprotic. Polar protic solvent are those solvent in which hydrogen bonding can be possible. Polar aprotic solvents are those solvent in which hydrogen bonding cannot be possible. So what are this? You studied earlier in the chemical bonding and organic and general organic chemistry as well, hydrogen bonding. So I mentioned here the hydrogen bonding part also. You must understand, and you are aware of that, then you can easily understand these two solvents. So what are the properties of polar protic solvents? Hydrogen must be attached to a electronegative atoms, so that a positive in charge is induced, and this positive charge is induced, and here some negative charge is induced, delta negative charge is induced, and this delta negative charge or lone pair can be attract other hydrogen atom of other compound, so the hydrogen bonding can be formed. So the first point mentioned here is capable of hydrogen bonding formation. So hydrogen must be attached on more electronegative atoms such as hydrogen, fluorine, oxygen, and nitrogen, etc. So effective sphere which formed is negative. Why is that so? Because oxygen is more electronegative. So here delta negative charge is induced, and in the solvent, if delta negative charge is induced, then whole sphere is negative. Okay, all right. And polar protic solvent is completed. Now we come to polar aprotic solvent. So here are some examples for polar protic. First we should write, such as S2O, NH3, ETHOH, HCOOH, CH3COOH. Basically, those atoms or those compounds in which hydrogen bonding is favorable. So what will be the impact on the product here is that we should also understand the hydrogen bonding property. Whenever these solvents are present in the reactant or as the form of medium, then you must aware in your mind that here hydrogen bonding formation can be followed. So maybe happened. So now we must understand the polar aprotic solvent. So in the polar aprotic solvents, no hydrogen bonding formation. Polar, I must write the heading. Polar aprotic solvent. So in the polar aprotic solvent, no H bonding favors. Mu is not equal to 0 because it is polar. No hydrogen bonding formation. And okay, write the examples for this, such as ether. Because there is no bond, no H is attached to fluorine, oxygen, or nitrogen. Mostly here we can write more electronegative atom. ठीक है? Okay. And ether, such as if we draw the figure of ether, Et, O, Et. This have polarity? Yeah, it has polarity. But this is what? Polar aprotic solvent, or we can say PAS in the short form, polar aprotic solvent. And can we say acetone? CH3, C double bond O, CH3. Here you see that no hydrogen is attached to fluorine, oxygen, and nitrogen. So no H bonding formation happened. So take more examples such as THF, tetrahydrofuran, CH3, CO, CH3. This is called as DMSO. DMSO is what? Dimethyl sulfoxide. Dimethyl sulfoxide. And after that, few more you should if you want to remember, then you can remember these also. Few more things, the like such as NN dimethyl formamide. HC double bond O and CH3, CH3. So let me summarize it for you guys, that you should understand here that oxygen, here can be oxygen, fluorine, and nitrogen. So if hydrogen is attached to a more electronegative atom, such as oxygen, fluorine, and neon, then this is called the polar aprotic solvent. If hydrogen is not attached to them, then it is polar aprotic solvent. So this favors H bonding formation, this doesn't favor H bonding formation. So why we study so? Because if product made, as I already said that if a product is like favors H bonding formation, then the stability of product can be differ, or can be dependent on these solvents. Next, come to the topic, like you should know about the few reagents, and here we are discussing about the organic reaction mechanism, then the reagents also the organic ones. So take a small heading of organic reagents. What are organic reagents? Example like electrophiles. So what are the electrophiles? You should know. Electro, here electro means electron, philes means loving. So see here I mentioned the reagents, and you guys also aware about the reactants. So there is a minor difference or a minor thin line between reagent, not minor, there is a difference in reagent and reactants. So what are them? What are that? reagents are added to a chemical reaction or test if the reaction is occurring or not. But reactions or reactants are the starting materials that participate in a chemical reactions. Okay, so this is the difference between reagent and reactants. Okay, reagents are not generally consumed in a reaction. They can initiate the reaction, or they can use for testing the reaction, that reaction occurred or not. So basically, if the product is formed, then we add phenolphthalein or methyl orange to basically the indicator. These are also the reagents to understand that the reaction happened or not. Okay. Then electrophiles. Yeah, we are discussing the electrophiles. Electrophiles are the reagents that are electron loving. So what can be said to this? An electron pair acceptor is the electrophiles. These can also said as Lewis acid. If you know, or if you study in general organic chemistry, the Lewis acid and the different types of acids are there. So you also understood already that what are Lewis acid. Lewis acid, basically the definition of Lewis acid is that substance which accept the pair of electrons. While other acids like arsenous acid and brosted laurie acid, you already studied earlier, that is defined by the ability of donate proton, like the H plus in the solution. So that is the definition I think I should mention here to revise you guys. So what are electrophiles used for? It basically attacks on where electrophiles are, they are electron loving. So basically these will attack on electron rich site. We can easily logically understood that, like Cl plus, Br plus, I am writing the example, I plus, NO2 plus, PCl4 plus, etc. Positively charged. Mostly these are positively charged, and but this is not the necessary condition. So we can make a note here also that all positively charged are not necessary electrophiles. Okay, and we can write the more examples here as well, like as cations of first A and second A group, NH4 plus, S3O hydronium ions also. This is the electrophiles. BCl3, BBr3, Bi3, BF3, AlCl3. These are the Lewis acid, as you already know, and Lewis acid are those also which want electrons. So these are also called what? Electrophiles. Electrophiles. Basically, we denote electrophiles such as E plus. So basically, they want the electrons. So these are the electrophiles. Okay. Let me ask you one example, and this is the famous one actually. So I can write in the pink. I will write it. CS2 is electrophile or not? Just think and tell me that it is electrophile or not. Those who says that CS2 is electrophile because these want what? There is positive charge here? No, positively charge is not there. So it will give you a doubt. So CS2 plus is electrophile, but CS2 have two electrons present in carbon. So they don't want electrons. So this is not the electrophile. So you should remember this. CS2 is not an electrophile. Why Lewis acid is electrophile? I forgot to mention here, because they have neutral charged but also have incomplete octet. Those who have incomplete octet are electrophiles. So we discuss here few concepts like polar protic, and electrophiles. Then you can write some more examples of electrophiles as well, so that you will remember in your notes whenever you are revising your notes. SbCl5, ZnCl2, FeCl3. Whenever you are seeing these types of reagents, you should also in your mind you always have to click that these are the electrophiles. Now coming back to nucleophiles, these are also the reagents. So in this we will discuss about the nucleophiles as well. Nucleophiles, put a heading on that. So first thing, an electron pair donor, that is electron pair loving and it is electron pair donor. Second thing is that it attacks on where it attacks on electron deficient side, because these have too much electrons or lone pairs, so these attacks on electron deficient side. Third, examples such as F minus, Cl minus, Br minus, mostly negative charge, but this is not the condition necessary that negatively charged anions are nucleophiles. So we can mention here as well in the form of note, so that we should not forget that. Note: all anions are not nucleophile. Okay, and as we already discussed the Lewis acid, because these have incomplete octet, then they will act as a electrophile, and here atoms or compounds mostly, sorry, compounds which have complete octet with lone pair, electron rich compounds with the lone pair. So you need to highlight this with lone pair. Let me highlight it with lone pair. So these are what? Nucleophiles such as PCl6. If you draw the figure of PCl6, PCl5 is neutral, but PCl6 is like what? Negatively charged. And is this like, okay, here are exception for the anions which I should mention. For example, PCl6 minus. So here minus is not the lone pair. Okay, this has a complete octet and the Cl minus is attached to this. So this is not the nucleophile, and also the BH4 minus. BH4 minus is also not the nucleophile. So this is the contrast, that all anions are not nucleophile. with the example, and neutral with non-pair. So write the example for that, such as NH3. In this, nitrogen has complete octet because in the outermost orbit, the nitrogen has 8 bonds and have the full octet, and the lone pair is extra. So this can act as a nucleophile. RNH2, R2NH is also the nucleophile. R3N is also the nucleophile. S2O is also the nucleophile. ROH is also the nucleophile. ROR is also the nucleophile, etc. Some special cases are there also. So make a note or heading. Special cases are like what? Special cases are such as CN. What CN? Cyanide. Double donor है. It is double donor. So this is good nucleophile. NO2. NO2 is also the good nucleophile. Okay. Double donor compounds, because these can bond with this as well from this. This can bond with two different sides. This can bond with two different sides. So we will see in the compound that and that is C triple bond N will form, or N triple bond C will form. This will matter because these have two different sides to donate. So you should know these examples, because when the reaction is predicted, then sometimes in, in in respect of C triple bond N triple bond C is formed with the compound. So keep that in mind. Similarly, NO2 also. Then we should discuss about so from till now we discussed the polar protic solvents, non-polar solvents, electrophiles, and nucleophiles. So as of now, we already have understood a few concepts which is of great uses, and use mostly each and every time. Now we come to nucleophile versus base. There is a difference between the nucleophile and base. So first you should know that what is nucleophile and base. Nucleophile, as I already discussed right now, and you guys understood already the definition of base. Basically, by the definition of Lewis base, the a chemical species that donates an electron pair to form a chemical bond. Basically, bases are those species which give its electron pair to the hydrogen atom, whereas nucleophile is different. Nucleophile are those species which give its electron to the pair of carbon, electron pair to the carbon atom. Okay, so this is the difference here. If I will make a chart, here I am writing the nucleophile, here I am writing the base. So write down the definition which I already told you just now. Can you write that? If you're not writing by thinking yourself in your mind, then you are not forming a logic and you are not participating in the study. So be clear to yourself that whatever I am studying, there is a why which is always happening in your mind at each and every step or each and every concept. This is the power of science, and this is why you should study science, because it gives all the solution to your why. Okay, and it will give eventually all the answers. Then only you can understand the concept in a more like you can visualize them also in a more different manner rather than just reciting it and learning it by skimming through it. So yeah, write it down. If a species give its electron pair to hydrogen, then it is what? I deliberately do it wrong in the nucleophile section because I want to know you guys and making aware yourself that I'm writing it, that the teacher or the tutor is writing right or not. You should also have the ability to judge others as well while studying, so that you can grasp a concept in a more different manner. So it will grasp like a deep of your mind in the first time as itself. So right now I will change the heading from here to here. So here I will write the base and here I will write the what? Nucleophile. So electron pair to H atom. Second, first is here is if a species give its electron pair to carbon atom. Okay, so it can be denoted by this. So you should remember this so that in the future you will use it. And how it will depend? So basicity order is like that. Basicity directly proportional to electron density and also the inversely proportional to size. Whereas nucleophilicity order of compounds directly depend on polarizability. I will discuss this right now. Just keep patience. So what does that mean? If basicity is directly proportional to electron density, where electron density is too much high, then the basicity order is like that and it is inversely proportional to size. But the nucleophilicity is like what? It is directly dependent on the size and also the polarizability, how the electron will polarize or how the electron is participating. If you having the mole polarizability to attract the other compound, so the basically the polarizability is like what? Polarizability is like the ability of molecule or a atom to become polarized. Meaning, what does that mean? It can develop a dipole moment when subjected into an electric field. So that is the meaning of polarizability. Mostly the uses of nucleophilicity is like that. If any compound or any molecule has the greater in size, then it is the more nucleophile nature because it can substitute easily the other atom, and it will attack on the carbon atom. So basically the halogen atoms is substituted in the electrophilic substitution reaction. Oh sorry, my bad. Nucleophilic substitution reaction. The nucleophile attack on the carbon atom and the halogen atoms will come out. Okay, so this is the nucleophilicity which is depending on this. So further we can classify it into the case 1, such as when donor atom are of same period. Example, when donor atom are of same period. Then the nucleophilicity order and basicity order are same. Nucleophilicity, like as nucleophilicity order and basicity order are same. Example such as CS3 minus NS2 minus OH minus F minus. So the nucleophilicity order is like that, and basicity order is also the same. Why is that so? It is because of the electron density. So electron density is more, and the polarizability, it can polarize more. Okay, so the polarizability is here more, and the electron density for the basicity is here more. So this is the order for both the same. But in case of groups, so I will write it like when donor atom is different. When donor atom is different, then different what? Different period, different size. What is like that? Such as basicity and अब क्या then basicity inversely proportional to nucleophilicity. Such as example is like that, like let's take an example F minus Cl minus Br minus I minus. So you should decide, as I already mentioned here, that this is like two different what? It is inversely proportional in the different period. So you should mention that what is the order of which thing, basicity, and you should decide the order of basicity and nucleophilicity. The first order shows of what, nucleophilicity or basicity. Just come to the definition. The definition says itself that basicity is inversely proportional to size. So what should be the answer of first? It is a nucleophile, because the more size it have, because iodine has already the bigger size and it has the negative size, so the anion of iodine is much larger than the iodine atom, so the nucleophile is great. So this is the order of nucleophilicity, and lower one the order of basicity. What? Because higher the size of the anion, then the lower the basicity, because it cannot give, because the electron density over the atom. Let me explain it further to you. I is bigger in size, so electron density over the atom is distributed more, so the bonding will form, the basicity is lower. For the to bonding the hydrogen atom, the basicity is lower the size, the basicity is high. So the charge is more. Charge means the electron density is less distributed in lower atom, and the bigger atom, the charge density of electron is what? Highly dispersed or highly distributed. So the basicity order decreases when the size increases. Let's just see the few examples more. So first definition, let's take some few examples, like as CS3, CS2, O minus, and O minus, CS3, C double bond O minus CH3 SO3 minus. So what are the order? The order is like, because these are of same group. First few are the basicity and the nucleophilicity order are the same, because this example is of the size of CH3SO3 minus is more, but here the thing is the charge is distributed in the mesomeric effect. So the charge density here is distributed, then the nucleophile is not good. So the nucleophile is good here. So the basicity order and the nucleophilicity order are same. Nucleophilicity order and basicity order here are same. Why so? Because the electron have high charge density, and so that the this is not delocated, this is not delocated, this is delocated, this is delocated. So the here the hindrance is more, and here it is delocated. See, you can easily predict the basicity order here, because the O minus has doesn't delocated, and the plus I effect is also putting there. So the basicity order is like that, because this is delocated. So the basicity order is like that, but the nucleophilicity order here defines, because O have the more negative charge, and here because of this cyclic ring, this has hindrance. So we will discuss case 3 about right now, and similarly the O charge is distributed, and it will affect a minus M effect, and it is also delocated into oxygen. So the nucleophilicity order is like that. And let's discuss the case third. Case third is what? Case third is the simple one, and you should put a note on behalf of that, like hindrance reduces nucleophilicity. So hindrance indirectly proportional to nucleophilicity. This thing you should remember. So we discussed in detail electrophile, nucleophile, and the comparison of nucleophile and nucleophilicity and basicity, and we discussed polar protic and aprotic solvents. So yeah, you should write one more thing also, the nucleophilicity order. Just you need to remember the series, so that you don't have to put much mind always to think. And a few examples of this also. Case third, such as CH3C, CH3O minus, CH3, CH3, CH2O minus. Basicity. So the basicity is like this, because the oxygen is not delocated, but the oxygen, it is like plus I effect is putting there. So the electron density is more. What? Electron density is increasing, so the basicity order is like that, but the nucleophilicity order is reverse, because this is more hindered and this is less hindered. Understood? Just write the one more thing also, nucleophilicity order. HS OH minus, N3 minus, Br minus, HO minus, Cl, sorry, my bad. After that, CH3, CO minus, Cl minus, F minus S2. Sometimes each and every topic you need to learn few orders of reagents as well as other things. So just remember this so that whenever any reagent come in front of you, so you don't need to identify that which nucleophile should attack first, because you already understood, or you already learn the nucleophilicity order, so you can give your answer on based or on behalf of that. So yeah, thank you guys. This topic is over, and we will discuss about a few more things in the future topics, such as what type of reactions, how the reaction proceed, how the feasibility of reaction, like that. Some few more things as well, like the leaving groups. We will discuss about the good leaving groups, the bad leaving groups as well, and then we will discuss the acid base reaction or different type of reagents that will react into the aromatic rings as well. Thank you guys, keep listening to me till here, and I think I have discussed each and everything in a deep manner and in a detailed manner as well. And if you left with any doubt, I think you don't have any doubt left. If so, then you can ask me in the comment section. I will provide the answer as soon as I see the doubt, and I will try to solve each and everything which I discussed in this topic and is in this lecture. So yeah, I hope that you guys will study and revise the things again and again, so that you can excel in your exam and you can understand each thing and each concept in a more like different manner, so that you can grasp the actual concept, what are the reason behind everything. So this is the main definition of science, or this is the joy of study chemistry. Yeah. So I hope I will see you in the upcoming lectures. Till then, keep hustling, keep working. Bye bye.